WarsawJS.
Again, my name is Dima. I'm working at Mapbox in Search API team, where I do our search engine. For our search engine, we use Node.js plus Rust. Rust for a part of code where we don't have enough performance from Node.js. And today I'll talk about processing big data files in Node.js. And first question that you may have, it's why do you need it? And actually, in current world, there is a lot of cases when you need to process big data files. You can have third-party providers, or you can be a third-party provider where you need export or import big data file into your system for later access. You can want to process large data file, or you want to process big data, just train your AI model or something like that. And yeah, first question for everyone. There is a lot of misunderstanding about Node.js. And my first question is, raise your hand if you think that Node.js is single thread. OK, it's a multi-threaded application. OK, keep it in mind. We'll talk about it later. For this talk, I prepared a file from OpenStreetMap. OpenStreetMap, it's an open source data provider that have a lot of data, geographical data. And I created 4.2 gigabyte file. It's a JSON file. And of course, when you create such application, you don't want to store so big file, like on S3 or some other cloud provider. You will try to compress it. And if you compress it, it will be like 650 megabytes of data. And then you want to process it somehow. In my example, I just read the file, decompress it, parse, format it somehow in my format that I use inside my application, filter some invalid data, it's just like some business logic, and then save it to database. And of course, if we're talking about some real large file, Node.js allows you only to use 1 gigabyte of memory, and possibly you will need to use like a max alt space size parameter to increase maximum of memory that Node.js can use. And if you run this application, we'll get an error. Like if you look on this example, this error says like a key max integer more or equal to length. Or if you created somehow so big data object inside your node, and then you want to export it, you want to JSON stringify such object, you will get invalid street length. What does it mean? It's because usually we run an application on 64-bit platforms, and 64-bit platforms support only 536 characters for a string. You can't get a longer string. And that's why you have this error. And the easiest way how we can process such file. Just imagine we broke this file into smallest file. Somehow, we don't know right now. And then we can apply the same logic. And for our 44 megabytes file, our runtime will be 3.2 seconds, and we used 1.1 gigabytes of memory. And it's pretty fast, actually. But what's the problem here? Can we make it better, and how it works under the hood? Actually, the code makes sense only if what you need to do in your code is a file processing. If it's a server that needs to respond to external requests, or you want to report some metrics by set timeout or something like that, this code will not work because we use just read file sync and zip sync. Everything is synchronous, and from the first line of code until the end, until our await, our event loop will be blocked. And there is an explanation why. Inside Node.js, we have two parts. First one, it's a V8. V8 is responsible to execute our JavaScript code. Second part, it's a C++, because JavaScript doesn't know about our operational system. We can interact with files. We can get some access. We also want to create some libraries that will work faster than Node.js can provide us, like, for example, some cryptographic libraries as zlib to gunzip our data, and how these parts interact one with another. Because if you want to execute C++, how we can do it? And an API does it. Because when you store variables, it's just some amount of bits in your memory, and different languages represent their data in memory differently. Like a JavaScript presentation is different than C++. And an API convert one variable format, for example, from JavaScript language into C++ and back. And an API allows us to execute C++ code. And yeah, it's how it works, but it's still one main thread. And when we call read file sync, it starts executing C++ code, but JavaScript code will be blocked because it's one main thread. And yeah, everyone can say, we can easily fix it. We can use read file promises. We can use async code. Yeah, but our runtime will be the same because only one thing that we did in this file, in this script, it's a process the file. The same runtime, we just unblocked our event loop, and we can we can process some requests when we read the file or something else. And yeah, let's look on our picture and figure out what changed. Here we changed read file to read file async, and it's where the libuv appears. Libuv, it's a library that do asynchronous operations in JavaScript. libuv has thread pool. Thread pool, it's like a pool of workers that is responsible to do our asynchronous work. We also have some UV thread pool size environment variable. You can change it. You can say like a process.env.uv thread pool size equals 6, and you will create 6 workers instead of 4 by default in your Node.js. And if you have too many asynchronous work, it can improve performance, but usually don't do it. 4, it's enough. And yeah, how it now will work. Now our read file will execute file API sync in C++. Then C++ will create a job for thread pool and for libuv, and libuv will execute the job in a thread pool. Yeah. OK, but what's wrong here? We still don't do anything until we read the whole file. And how we can improve it? We can use Node.js streams. Streams, what is it? It's an API that allows you to do not read whole file, just read some chunk of the information. Streams allows you to process information like chunk by chunk. Like how it works, we have producer. In our case, it's a file API. File API generates a chunk of information and store it in a buffer. And then our consumer can subscribe to the buffer and can read the information from the buffer. But in our previous example, we use JSON. And JSON, it's a not good format when you work with streams, because you have to know all structure before you start to parse. It's possible to work with JSONs in streams, but it's very difficult. Don't do it. And one good example how we can store our data for streams is a CSV. Everyone knows about it. You exactly know where, like a CSV has columns and rows, and you can just search for a new string delimiter, and it will be your first item. And then search for a next string delimiter, next new line delimiter, and it will be your next item. In Mapbox, we very often use the JSON format, and the JSON format it's just like a JSONs where each item we store on a new line. Here's just example of such data file. Yeah, now let's look into our picture how it works under the hood. Now JavaScript just orchestrates of entire work. It doesn't. We don't do whole work in Node.js. We just like please create a read stream, and then create a gzip stream, and we gzip stream subscribe, create a file stream. Now, like a first step, we call file API stream. File API stream will create a job in libuv. Then we call create gzip stream. Gzip stream will create a job for libuv, for that lib. And now we have two independent jobs in two threads that communicate between each other through streams. And it's why Node.js is multi-threaded application. We didn't use workers or something else. Just like our code works in two different threads. One really important information about streams. Streams have back pressure mechanism. It's you can specify how it's a parameter high watermark. High watermark parameters allow you to set how many items you want to store in your buffer. And because producer can produce information very fast, for example, 100 items per second, but your customers can, for example, initialize just 10 items per second, and your buffer will grow and grow and grow. And these parameters allow you to store exactly so much items as you want. When buffer will reach this amount of data, it will push notify producer to stop produce the data. And yeah, there is stream example code. We create file read stream, then we create gzip stream, split stream. It's a stream that splits information in our end.json file, like line by line. Then we have some business logic stream where we do our logic, and then we just pipe one stream into another, and that's all. It will work. And for our 646 megabytes of file, our runtime is 34 seconds. It's 3.5 faster than previous non-stream example. Yeah, there is one good example how you can use streams with more readable in more readable format. It's a pipe operator. You just create your streams and send it in and just use pipe, and it's much more readable than previous example. Yeah, now let's talk about performance, how we can make it better. And if you run Node.js with CPU profiler command, you will get something like this. In this example, we see that we spent 7 seconds just for regexp, where we search for our new string delimiter. And yeah, how we can improve it? It's a binary split. When we read file, Node.js sends us buffers. Buffers, it's a Node.js representation. It's a Node.js class to represent binary data. And when we search for /n in our binary data, we convert binary into strings. Then we split the string by delimiter. In Node.js, strings, it's immutable data. It means that Node.js needs to create a new 2 strings, copy the whole data, and then you can use it. And yeah, we can use binary split instead of it. We don't need to convert the binary data into strings. We can just search. We can convert our /n into binary representation, and then search in our binary information, the delimiter. And Node.js buffer has good API where you can split the buffer into 2 chunks, and it will not. Node.js will not copy the data. It will just split it. And yeah, if we profile the application right now, we'll see that main thread spent 19 seconds or almost 20 seconds to just parse our JSONs. And our event loop was blocked. Event loop utilization 98%. And okay, yeah, and how we can fix it? I mean, Node.js has worker threads. It's how we can split, remove some work from main thread and improve our performance. Yep, we can just add worker thread. As an example, create 2 workers, use the same binary split, and then when we have an item, we can send it to a worker. Worker will parse the JSON, do business logic, but in reality, it doesn't work. Because it will improve performance slightly if you do really, really compute-intensive business logic. But if your business logic is not so compute-intensive, you will get almost the same performance, or it will be slightly better, because you spend too much time to communicate between your main thread and between your workers. You will also spend a lot of time, because when you send the data into your worker, you need to copy the data. Yeah, Node.js has possibility to like a set parameter transfer list and send a buffer without copying it, but in reality, it doesn't work. And and there is a solution. It's a batch split. How it works? We still have our producer. It's our file stream. We send it to a buffer. And then instead of searching in main thread for our delimiter, we can say we'll create batch with at least 2 items. We just add 2 chunks in our batch, and only in 3rd item we'll start searching for our delimiter. And when we will find our delimiter, some part of our 3rd chunk will be in first batch. Next part of the chunk will go to a next batch. It removes a lot of, and we can create batch with 100 items or I don't know 1,000 items. It just depends of how big is your item. And it removes a lot of work from main thread, because now main thread needs to find delimiter only in 3rd item and like possibly 100 items, real JSON items in our first 2 chunks. And now we can send this batch, our splitted batch, into worker pool. And yeah, our runtime will be just 10 seconds. It's 3.5 times faster than our stream version. Yeah, I just use through to concurrency library. It's a library that allows you to currently process streams. Yeah, what do you need to remember? When you process such files, your script should be repeatable. It means that if you run your script and something fails, and if you run it again, result of your work should be the same. It should not create new items in your database. Next, do not mute errors. Do not do then cache, then just some console log. You will lose such errors, and you'll have a lot of problems.
Great presentation, really deep dive into processing data in Node.js. But I have maybe a silly question, but actually why Node.js? I mean, did you look into other languages, other tools that would be more suitable for this?
I have good answer. First, it's a why not. We are JavaScript developers. Why not? We do everything with JavaScript. And second, sometimes you have a lot of code that was written in your company, for example, in JavaScript, and you don't want to create duplications of the code in another language. You just want to use one infrastructure across company, and it can be an answer.
Wow. Who else has a question for Dzima? Of course. Yes.
This is question related to also previous talk. And I would like to ask, you said that it would be hard to process JSON. Do you think would it be possible to process XML file with stream? Thank you.
Yeah, XML file has the same structure as JSON. You need some information from previous node. You need to just find all open and close. It's possible. It's also possible with JSONs. It's possible. It just adds complexity to your code and possible errors.
Okay, thank you. I'm satisfied.
Wow. Another great question. Is it possible? I'm learning here that anything is possible if you're willing to invest the time and effort. What I understood is that you think it might be not a waste of time, but a lot of time and energy invested using JSON. Is that correct?
Yeah.
Okay, that's what I thought I understood. We have time for another question. Anybody got one? Come on. There must be something that, okay, do you have a question for our audience about your presentation? Let's see. You have no questions?
Was it good enough?
Yeah.
Okay, cool.
Thank you so much. Thank you, Zima. Okay, folks.